Buddy, let me talk in this video about one of most interesting sorting algorithm, name it Heap Sort. Until now, I think this algorithm is the best algorithm for sorting in two places for the space complexity and time complexity. So let we think how Heap Sort. Heap Sort work with a tree. So if you think you have this tree, you have this node and this node this node. When you have node connected to other node overline this name the tree, and we will go in details about tree. So I have here is 1, here is 4, here is 6, and here is 2, 5, 8. If I want you to represent it in the heap way, heap say okay, every parent have 2 child, and the child in the left will be equal to will be located in 2k, and in the right will be located in 2k plus 1. K the index of the parent. So what I mean by that, I will make it clear for you in a moment. So if I suppose I have this array, okay? So the parent will be first element in the array. So in the index 0. So I would suppose which the parent I have it here. I have 1 is the parent. So parent is will be in the index 0. So where that child for this parent will be located? Okay, the parent for this child will be located in the 2k and 2k plus 1. But you cannot use 0 as indexing. You start from 1 as indexing. You say, okay, I will start from 1. So the child who located on the left will be located in location 2k. So 2 multiplied by k. This one is k by 1. That means 2. That means second location will be for the left kid. That means this one. So this one will be located here. What about right kid? I mean this one. Where is located? By 2k plus 1. What's the k I have for the parent? 1. That means 2 by 1 plus 1 is a 3. That means location 3, you will have this kid like 6. See? Let me continue with other kids with the other parent. So let me move to the next. Which parent you have it now? We have 4. So 4. If you see it 4 here, have 2 kids, left and right. So let me start from the kids in the left, this one. So left will be 2k. What the parent index is 2. So 2 by 2 will be 4. So that means in location 4 you will have 8. What the kids in the right is 2k plus 1. What the k for it is 2 by 2 plus 1. That's mean location 5. So this one 4, this one 5. For 5 you will have this one, the right kids. It is 5. So 5 located in location 5. Now we move next for the next one. That means we are talking now about 6. So if you say okay, this is 6. Is this 6? Yes. 6 have only left kids. So I would say this one 2k. Well, the 6 index is a 3. So 2 by 3 equals 6. So in location 6 in the array, you will have 2 located. If you see it, here is it. So did you see how I represent the tree using array? It's really easy. Every node have 2 kids, have left and right. The left kids will located in location 2x, and the right kid will location 2k plus 1. This is the way of representing the data, but this is not the way that heap sort working. How heap sort working? Heap sort, you first look through the largest element in the array. You say how you find it. Okay, is the 5 greater than 4? Yes, so do replace between 5 and 4. So that means okay, I will remove this 4 here, 5 here, and I add 5 here and 4 here. Now you did this part. Now you go to the same operation. You compare this one with this node. Is 8 greater than 5? Yes, so do replace it. Moving it up. So you say okay, 8 here, 5 here. Now you say okay, now I'm done from this part. So is the 8 greater than 1? Yes. So if yes, do replace. So take 8, move it here, take 1, move it here. 1 and 8. Now you complete this section. You say okay, let me compare this part. Is the 2 let me hope I just removed this line by mistake. So you just compare, is 2 greater than 6? You just in this point, let's just remove this line. Is this 2 greater than 6? No, you don't. So you don't need to do any change. You just go here and compare 6 with 8. Is 6 greater than 8? No. So 8 is the greater than element. Now you have the 8 is greater than elements, but you cannot remove it directly, because if you remove it, the tree will be corrupted. So you cannot do this process with the tree. You have to delete any element. First, I think you have to move it in this way. You put it as the last element. What I mean by that, you just take 6 and 8. You say, okay, I would add 6 here, 8 here. Then I just replace it again, 8 with 2. You say, okay, I would add 2 here and 8 here. So now it's really easy for you to remove this node. So this node is going to the last element in the array. That's mean 8. Okay, then you continue. Say, okay, now I don't have this node. Let me continue same process. You say, okay, I will compare 1 with 4. Is 1 greater than 4? Yes. So do replace. So take 1, take 4. Should be 4 here, 1 here. Now you have it. Yes. So just go next. 4 with 5. Is 5 greater than 4? Yes. So do replace between them. So take 4, 5. So bring 5 here, 4 here. You are good now. So just remove this thing. Now you compare 5 with 6. Is the 5 greater than 6? No. So just keep 6 in its place. So now compare, is 5 or 6 with 2. Is 6 greater than 2? Or 2 greater than 6? No. So keep 6 in the place. Now, okay, I know 6 is the greater than element, but now I have to move it here to delete it. So I cannot delete it from this location. So let me say, okay, do replacement in this side, just move it at 2 here in this way, at 2 and 6. So now I have 6 as the last element. Now I could, hey, it's time to remove you. I don't need you. So I just add it here in the end and remove it, and continue same process until by end you will have, then you will take off 5, then 4, then 2, then 1. If you see how it's sorted. So now just let me think about how would be the big O for this tree. So if you say it is 3, you have 1 node, then you have 2, then it's get double it. That means this one take log n. But this operation for moving element between this node, and this node, name it heapify. Heapify. This heapify take log n. Okay? But if you see, we did not do heapify one time. For finding every element, we would do heapify. How many elements we would have in this array? N element. So finally, O of the heap sort will be n log n. Log n for heapify, and n for n element, because we do heapify for n element to sort the array. This is a basic example I could show you about heap sort. Let me go to the implementation and understand how we could implement it. But finally, before I go to the implementation, you cannot find sorting algorithm could bring you the code complexity less than n log n, because this is the best sorting algorithm. You cannot find less than it. I also say this is best algorithm because not only time, for space also, this take O of 1 space in comparison with other sorting algorithm, because here he did not use addition array, he used same array and tried to sort the element inside array. Yes, here we're done, and thank you for watching, and see you next.